Cordially greeting, we are the group Chuseok Spirit, composed of Yasmin Diaz, Juan Maldonado, Paula Prieto, Joan Sanchez, Antonio Zarate. This project was developed for the course Engineering of Movement, in which art, mechanics, and design are integrated. Each group member participated in the creation of the mechanism using artificial intelligence, and through software such as Inventor and Fusion, the necessary adjustments and simulations were carried out, resulting in the automaton presented below. Our objective was to develop a functional automaton integrating 3 movements powered by a motor, which, through a gear train, generates the rotation of the cam and the movement of a 6-bar and a 4-bar mechanism.
Each movement of the automaton was developed to represent the day of Chuseok in South Korea. Therefore, the first movement is based on a cylindrical cam follower set that produces the rotation of the characters, representing the Gangang Zule dance. At the same time, another character can be observed performing the jessa as a gesture of gratitude to the ancestors for the harvest and a prosperous year using a 6-bar mechanism. Meanwhile, the moon rises through a parabolic-shaped window, stopping at its highest point. First movement, cam follower assembly cylindrical cam. In this diagram we see the profile of our cylindrical cam. On the horizontal axis is the rotation angle and on the vertical axis the follower displacement. The graph is divided into 6 harmonic segments, each describing the same sequence, rising smoothly up to a maximum of 10 mm and then descending without impacts. The important point is that the cam completes 3 cycles per revolution. This means the follower performs 3 perfectly repetitive jumps every turn. There are no flat spots or pauses. The curve rises and falls immediately, ensuring continuous, rhythmic motion with no loss of contact. The choreography is simple. The rhythm dictates alternating jumps. When one dancer rises, the other descends. Mechanically, this is encoded into the cam profile, rise for lifting, return for lowering without overlap. This prevents both from being up or down at the same time.
Design and construction of the mechanical system. Transmission systems, 2 gear trains. Gear train 1. The main gear train receives an input speed of 100 revolutions per minute from the motor. This system, which includes 6 spur gears, reduces the speed to 10 revolutions per minute, transmitting motion to the cylindrical cam and to the second gear train. Gear train 2. The purpose of this secondary gear train is to transmit motion to the 6-bar mechanism and the music box, with a 1-to-1 ratio, 4-bar mechanism. The movement simulates the moon rising into the sky through the wall of a Korean temple using a 4-bar system. This mechanism receives motion from bevel gears connected to the 6-bar mechanism, which is classified as a Barker GCRR, crank rocker, type, where the input link rotates a full 360 degrees, satisfying the Grashof condition.
6-bar mechanism. In this 6-bar mechanism, the frame acts as the fixed support. The movement includes two kinematic chains working in parallel. One drives the system and the other shapes the gesture. When the driving link rotates, the first pair of bars amplifies the displacement, while the second pair smooths and guides it. The resulting coupler pushes the character's arms forward with a longer and more controlled trajectory, and then retracts them. The geometry of the system defines the amplitude and synchronization of the gesture, ensuring that both hands extend at the same time without phase shifts. It is a precise mechanical choreography, where rotation becomes rhythmic extension, as shown in the image with the construction of the mechanism and its respective dimensions. Component manufacturing. Below is a table showing the different components distributed for each movement, along with the material and process used. Prototype and operation. The final prototype operates using 2 gear trains that reduce the motor speed and distribute motion to the 3 main mechanisms. First, the cylindrical cam converts rotation into harmonic vertical motion that produces the alternating jumps of the character. Then, the 6-bar mechanism amplifies and smooths the trajectory, extending and retracting the arms with a stable and wide gesture. Finally, the 4-bar mechanism synchronizes the simultaneous extension of both hands, maintaining uniform motion without phase mismatch.